Hello, my lovely warriors. Welcome aboard. Do let me know if you can see me and hear me loud and clear. This is your Captain Shreyas, and I'm going live. And this is the Pathfinder series. This is for all the 12th standard and the dropper students. And today's session is about light waves. So we're going to open up NCERT one by one, and we're going to see all the important points in the NCERT, and I'm going to mark it. So all my handwritten markings on the NCERT, and then we're going to do JEE practice, the JEE questions. So both the things will be covered in today's session, board's perspective and JEE perspective. That's what we're going to do in today's class. So it's all about interference, Young's double slit experiment, the single slit experiment, Hygen's principle, and yes, we are going to end the class with polarization. So nice to see all of you. Hi, Ankit. Well, yep. Oh, Ankit, you're feeling low with your preparation. Well, Ankit, I guess you need a lot of motivation out here. One thing, first of all, keep attending the live classes. That's where the energy builds up. Number two, if you have some friends, positive friends, make sure you discuss some good questions with them. And yes, please do not watch any negative things or stay away from negative people. All right. So please try to do these three things. Hopefully that will help. Hello, Samyak Bora. I'm very good and nice to see the Vedantu students out here. Welcome aboard, welcome aboard, welcome aboard. Hi Murli, hi Amjad. Thank you for all the love from Kerala. Welcome everyone. Hi EGL, hi Manikandan. Welcome. So, those of you who do not know me, that's my quick introduction slide. I hope you have seen it. But in case you want to know more about me, you can definitely check me out on my Instagram handle. And yes, before we begin today's session, you need to do me a small favor, and that's it. You need to go ahead and smash the like button down there so that it helps me gain more access to more number of students. A lot of students who do not know this channel will get to know about this channel because that's how YouTube algorithm works. Not just that, it also helps you because then when you open up YouTube, and then all my recent videos, all the upcoming videos will pop up in your homepage. Else you might miss out the important classes, updates, and notification for your JEE preparation. Yep, Sanjay, I'm taking lots of micro courses for 11, 12. One is Ydse Verma, one is Erodive micro course, one is problem solving micro course, one is derivation micro course. It's all there. So make sure you watch all of that. Samyak Bora, oh my God, thank you, bacha, for all the love from Maharashtra. Ram Ram, Namaskar. कसा आहे बरा आहे आणि मी पण पुण्यातच आहे आता. So I'm right now in Pune, and that's the reason why I do not have the smart board. So once I go back to Bangalore and I get back to my studio, I'll be having access to our smart board. All right. So hi Madhusudan, welcome aboard. So now that you have already smashed the like button, thank you, and also thank you for hitting the subscribe button. Also, quick reminder for all the 12th standard and dropper students who have not yet enrolled in the JEE crash course, make sure you check out the link which is there in the description box, because for all of you who need that additional support, additional motivation, additional push, and you're not happy with your current level of preparation, even if you're enrolled in coaching, this is the one thing which is missing in your life, which you should take up because it's hardly for 9,000 rupees after discount and using my coupon code. So make sure you join the live crash course for JEE, 45 sessions, sorry, 45 days, 90 sessions crash course with mock tests and every report that you need for cracking JEE. So let's open up NCERT, and yes, the chapter name is Wave Optics Chapter 10. Yep, I hope you all have NCERT with you. Thank you, Batini, Aswita. Thank you so much. Oh my God. Well, Samyak, I'm in Chinchuad and I'm not sure how far or close it is. And I hope you are safe because the cases in Pune are really rising in crazy numbers. Oh, and happy Pongal, Ramya. And I hope you enjoyed yesterday's thermo class. So open up NCERT, guys. And I'm also going to open up NCERT from my end. So I hope you guys can see NCERT, which I just have opened up behind me. Yeah, there you go. And what I'm going to do is quickly start telling you all the important pointers. So I just hope you all have your NCERTs and your highlighters or your pencils so that you can start marking. And do not worry, I'm also going to give you the PDF in the new Telegram channel. If you have not yet joined the Enthuse English channel on Telegram, join it, because you're going to get the PDF of the NCERT with my marked notes and handwritten and my own handwriting, all the important pointers, and also the session PDF of today's problems. All right. So the introduction part is fair enough. There is nothing great over here, but this is more like history than anything else. Okay, so that's okay. So um, well, this is an interesting paragraph. You can do this more like a reading exercise. Do this like a reading exercise, because this paragraph is a little bit interesting. So it is very interesting. Okay, so I'm just going to put this over here. Just have a read through this, and it's all about how light travels. And a lot of students feel that light travels in a straight line. Well, that's correct, unless it encounters some obstacles. And uh, the moment light encounters obstacles, it bends around that corner. So light can bend, but that's around some obstacles, some slits, some, that's called as diffraction. Yep. So how cool is that? Now the first point over here is Huygens principle. This is very, very important. You cannot afford to skip it. So basically, what the definition of a wavefront is given over here. Okay, so the locus of all the points where the disturbance reaches simultaneously and have the same phase. Okay, so that is called as a wavefront. So the definition of a wavefront, so all the points which encounter the same disturbance simultaneously. So for a point source, if you see all the points on the circumference of a circle, all the points will oscillate up and down simultaneously. So that's a circular wavefront. Okay, so that's how it is. And so that's what is mentioned over here. The locus of points which will have the same amplitude and vibrate in the same phase for a point source will be a spherical wavefront. All right. And for a large distance, this is very important. This was in fact asked in JEE. The small portion of a sphere can be considered as a plane wavefront. This is very interesting. This was asked. This is asked previously. This was asked in previously. Okay, in different ways. So very, very important point over here. Now, this next paragraph is all about Huygens construction. So the construction of a wavefront is being mentioned in this paragraph. So just read this, and the most important line over here is each point on the wavefront acts like a secondary disturbance or a secondary source emitting newer wavefronts, and when you join the common tangent after some time, the common tangent gives you the new shape of the wavefront. Meaning, whenever, let's say for example, okay, so let me just draw over here. So say for example, you have a wavefront like this, and these are the points on that wavefront. These are the points on that wavefront. These points will act like new sources. They will emit new wavefronts like this. These are called as secondary wavefronts after some time. And when you draw the common tangent to all of them, this becomes your new wavefront. The previous one becomes your old wavefront. So that's what has been explained in the paragraph. And this is how you do the Huygens construction. Okay. Now, this is also a very important line. Hygen argued that the secondary wavefronts that you draw should be only in the forward direction and zero in the backward direction. Oops, can I just do undo over here? I don't know. Or maybe I just have to do erase. Okay, yes, there I go. So zero in the backward direction. Very, very important. That means whenever you draw the secondary wavefronts, do not draw it backwards. This is not allowed, meaning over here. So do not draw backwards. So this is the wavefront backwards. These are the wavefronts in the back. The back wavefronts should not be drawn. Remember that. It always propagates in the forward direction. All right. So based on this, you can explain the reflection and refraction. So that is the proof over here. So this entire paragraph is about the proof. You can look at this for refraction as well as reflection. So you can see over here, this is nothing but your Snell's law, nothing else. This is your Snell's law. Okay, so sine I1 and this is all about critical angle and all those things. So another important thing over here, frequency remains same when the medium changes. Lambda, speed, okay, they are basically different when the medium changes for refraction. Okay, so lambda and speed will change, speed of light will change, but when but the frequency always remains the same. That is also another important thing. This is Snell's law of refraction, like you can see over here. You have seen this in ray optics. Okay, so Snell's law, n1 sin 1 sin I is equal to n2 sin r, or n1 by n2, or n2 by n1 is sin I by sin r. That's the same thing. Okay, this is about critical angle. Don't worry, you will study this. You will study this in ray optics. So this is more of ray optics part. Okay, so for now it's okay, even if you don't know about critical angle and all of that. Yep, yep. Okay, shall we go ahead? Yes, Dakshin. Hello, welcome aboard. Ramya, yes, I'm doing PYQs of thermo simultaneously in the sessions, and next time I'll do one thing. I'll explicitly mention which one is PYQ. Last time probably it was just left out which were PYQs, but yes, next lecture onwards I'll make sure that the PYQs are explicitly mentioned with their year numbers. Okay. For reflection, we all know the laws of reflection. It's very simple. Angle of incidence is angle of reflection, and all of them are in the same plane. Okay, so those are simple things, nothing great over here. Okay, so this is a law of reflection, and that's what is mentioned over here. Okay, so the angle I is equal to angle R, and fair enough, nothing great over here. Now, there was a time when JEE Mains has asked a question on Doppler effect in light. Yes, this is Doppler effect in light. So please make sure you read through this paragraph once. Now, one way to remember this blue shift and red shift. Okay, so Doppler effect, which will have red shift and blue shift in terms of light. This is that paragraph which is there over here. One way to remember that is just imagine a vehicle, okay, which is going away from you. Imagine this is a vehicle which is going away from you, probably something like this. Okay, this is a car which is going away from you. Now, remember in sound, when the source moves, then what happens? When the source moves, then you will hear a different frequency. Depending on whether it is coming closer or whether it is going far away, you might hear more or less. Do you remember that? Yeah. So in sound, what happens is when the source moves, then you hear a different frequency. Same way in light, when the source of light moves, but with very large speed, not small speeds, with decent amount of speeds in thousands of meters per second, then the color of the light changes, and that is the Doppler effect of light. When light moves away, then you will see it as red. So think of a car which is going away. What will you see? The red light, right? So this car is basically going away from you. When it goes away, what will you see? You're going to see red light behind it. So that's one way of remembering it. So this is red shift. And the opposite of red color, don't see green. You are not going to see green. Red is highest wavelength. The shortest visible wavelength will be violet in color. So that's why it is usually called as blue shift, because violet blue almost looks similar. Okay, so that's why it is called as the blue shift when it comes closer. So if you have white color light and it has made of different colors, and when it goes away, you will see it looks reddish, and when it comes towards you, then you are going to see bluish shades out here. All right. Hi, I'm Diya. Selva Kumar. Yep, you're going to see me on the smartboard very soon. Yep. Don't worry. Now, the formula for remembering that is right over here. Del V by V is equal to minus V by C. Now, this on the left hand side, don't get confused. It is actually frequency. It's not mu. It's not V. It's mu. So think of this as del F by F. So this is frequency, and V stands for the speed. This is the speed of the source. Okay, so this is the speed of basically the source, and C is obviously the speed of light. That means it is 3 into 10 to the power 8 meters per second. So the change in frequency, this is all frequency. So the change in frequency that you will get upon the original frequency is negative speed of source upon speed of light. That negative stands for just the sign convention, but it is understood that when you go away, when the source is going away, then you are going to see redshift. That means larger wavelength, that means smaller frequency. Okay, so when you go away, then you see smaller frequency, and when the source comes closer, then blue shift, that means shorter wavelength, that means higher frequency. Is that clear? Yep. So Sravana, this is not a ray optics lecture, this is a wave optics lecture. Yep. So this is important from board's perspective as well as JEE mains perspective. This Doppler effect of light, this formula especially, and there is an example on that. Please go through this example for Doppler effect of light. Okay. Now coherent and incoherent sources. So simply put, coherent means they are in sync with each other. You know the correct relationship between the sources. So when you basically know what is the correct relationship between the sources, that's when you call it as coherent sources. And when it's haphazard, sometimes the light is emitted, sometimes it is not, sometimes you get a crest, sometimes you don't get a crest, it could be anything, then basically it is incoherent. And then the interference is not determinate, meaning you cannot precisely gauge what kind of interference is happening. So whenever you study interference, you always have coherent sources, because you know what are you going to get from both the sources. You know the exact relationship between the wavefronts, whether that's a crest with a crest or crest with a trough or anything else. So keep this in mind. Okay, so whenever waves meet at a same point, then you superimpose them, and the resultant displacement is produced by the vector addition of their respective phasor. Remember phasor addition. So this is all about phasors, phasor addition, phasor addition. So if you remember, if you have two waves of certain amplitudes and they meet, then you take each amplitude as a vector, and the angle between the two phasors should be the phase difference. The angle between the two phasors should be the phase difference, and add them vectorially to get the resultant amplitude. Yep. So light optics means wave optics. Yes, wave nature of light, not the ray nature of light, not lenses, not mirrors. Here we are studying the wave nature of light. Okay, so very, very important out here. And all of this is fair enough. Okay, this is all fine. And in fact, I will put up a formula right over here for you. So resultant amplitude is amplitude of 1 plus amplitude of 2 vector wise, but magnitude wise it is nothing but root of a1 square plus a2 square, this is vector addition formula, plus 2 a1 a2 cos del phi. Del phi is the phase difference between them. Similarly, for intensity of the resultant wave, it is nothing but, okay, intensity of the resultant wave is nothing but I1 plus I2 plus 2 times root I1 I2, and there you have cos, okay, del phi. So this is the formula which you have for intensity and for amplitude. Keep this in mind. So very, very important. I have just put it up over here. Like you can see, there are different examples right over here, how the waves are meeting at different points. And you can see, because the waves have to travel different distances, so there is a path difference which is introduced between the waves, and that path difference can lead us to find out whether it is constructive or destructive interference. So the condition for constructive and destructive interference is right over here. So when the path difference is n lambda, okay, then we have constructive interference, and the resultant intensity will be 4 I naught. Okay, so if each wave has intensity I naught and I naught, when you use this formula which is written right over here, I1 plus I2 plus 2 root I1 I2 cos del phi, then you will see that if I1 is equal to I2, the resultant intensity will be 4I1. 4I1. So it is 4 times any one of the intensity. But when the path difference is odd times lambda by 2, then you have destructive interference, and the resulting intensity will be 0. So I do not like the way it has been written over here. I would prefer writing it like this: delta x is odd times lambda, okay, lambda by 2. And over here I will write delta x is just n lambda. So both for constructive and destructive have mentioned it right over here. I hope this is clear. Yep. So what do we mean by phasors, Ankit? So phasors are those quantities which represent an oscillating term. Remember, in SHM, I had told you any oscillating, a quantity, I can draw the corresponding circular motion, because when you project the circular motion, the projection of it is oscillation, the simple harmonic motion. So if you go reverse, if you have an oscillating thing, then whose shadow or whose projection is that? So it will be the shadow of some circular motion. So when you draw that circular motion, that thing which is rotating, that is called as the phasor. The length of that rotating thing, the radius, is the amplitude. The speed with which it rotates is angular frequency, and so on and so forth. So phasor is a hypothetical quantity just to analyze the problems. Okay, I hope this is clear. Hi Samyak. Hello Thalapati. Okay, welcome aboard. And very good, Selva, if you are able to solve HC1, but you are not able to solve JEE mains questions. So Selva, start solving easy questions first and then go to the difficult questions of JEE mains. Okay, just leave a comment after the session and I'll tell you how to approach. It's not so simple also. I'll tell you what you can do. Okay, just leave a comment after this. All right. Now, in general, the intensity formula is this. Very important formula. I is equal to 4 I naught cos square phi by 2, or phase difference by 2. Intensity at any point is 4 I naught cos square phi by 2. Very, very important. And when phi is 0, 2 pi, 4 pi, then it is constructive. But when it is odd pi, then it is destructive interference, which leads to zero intensity. Keep this in mind. Standard formulas, very, very important. All right. So, okay, and this is interesting. This is very, very important paragraph. A lot of people are going to skip it. That's why you are attending my class. When the phase difference is changing continuously, that means the sources are incoherent. So there is no constant relationship between the two sources. Then you are not going to use the formula which is mentioned over here for adding their intensities. Instead, you are going to just add their intensities for incoherent sources. Sridharma Agarwal, I'm very good. Hi, science enthusiast. Welcome aboard. So, it's just going to basically add their intensities. Keep this in mind. Very, very important paragraph. So, for incoherent sources, the resultant intensity is I1 plus I2. There is no 2 root I1, I2 cos phi. Keep this in mind because their phases are changing rapidly with time. Read this. Their phase is changing rapidly with time. That's the reason why they are incoherent sources. Understood, my warriors? Ramya, obviously it is going to take some time. Hold on for that. Okay, perfecto. So till this point, I think this is fine. Let's start doing some problems and then I will go to Young's double slit experiment. Ready for some questions, guys? Ready for some questions, my warriors? Yep, ready for some questions. Till this point, everything is clear. All right, so there we go. The first question coming up on your screen, and here it is. Hello, Ria, welcome aboard. Which phenomena cannot be explained by Huygens principle? More than one can be correct. Reflection, refraction, diffraction, atomic spectra, radiation pressure. Think about it. Which of the phenomena cannot be explained by Huygens principle? Reflection, refraction, diffraction, atomic spectra, radiation pressure. Think carefully and let me know. Think carefully and let me know. Okay, come on. Is it reflection, refraction, diffraction? More than one can be correct. So, which cannot be explained by Huygens principle? Which cannot be explained by Huygens principle? Think about it. I just told you in NCERT, reflection is there. Reflection can be explained by Huygens principle. Refraction also can be explained by Huygens principle. Diffraction also can be explained. Atomic spectra, that happens via the quantum physics, where you talk about quanta of energy, which is photon. Radiation pressure, also pressure, that means force, that means momentum, that means particle, that means photon. These are based on the particle nature of light, whereas Huygens principle talks about the wave nature of light. So the wave nature of light can explain reflection, refraction, and diffraction, but not the particle nature, which is basically the photon. The photon nature cannot be explained. So hence the correct answer should be D and E, not ABC. Be careful. ABC is correct. That means it can be explained. Which can't be explained will be D and E. Got it? Very good. Very good. I can see all your answers, but looks like some of you mentioned the exact opposite, which can be explained. So which cannot be explained is D and E. Moving on to the next question. Two sources of waves are called coherent if both have same amplitude of vibration, both produce the waves of same wavelength, both produce wave of the same wavelength and have constant phase difference, both produce wave of the same speed. Yep. Think about it. Think about it. Think about it. Vicky, I'm going to conduct a class tomorrow morning at 11 o'clock. Just watch that. You will get to know everything about JEE mails. Yes, that's what happens, Ankit. Be very, very careful. Don't get too conscious. Don't get too nervous. Be free and read everything carefully. Two sources are called coherent. Coherent means they must be in sync. And if they are in sync, you need to know the relationship between each other. That means they need to have the same wavelength, they need to have same phase difference, which is maintained throughout time. Hence, the correct answer is option C. Okay, so when their phase difference is constant, that means there is no change in the phase difference, it's always maintained. Then you will see, you can judge what kind of interference will be produced, you can predict what is going to happen. So that predictable nature is only given when the sources are coherent. Got it? Very good. Moving on to the next question coming up on your screen. There are two waves. Y1 is 4 sine omega t, Y2 is 3 sine omega t plus pi by 3. They meet at a point and interfere. What is the amplitude of the resulting wave be approximately equal to? Yes, Vicky, I'm going to do lots of sessions. Like you can see, this is the second session already this week, and there are more sessions. Tomorrow also there is a session for you. So lots of sessions are there. Don't worry. Yep. So Ramya, I will let you know about that on Friday when my smart board is going to be back. On Friday, most likely I'm going to tell you about that. And apart from that, there are some more things which I will tell you. Yeah, Selva, almost 11 standard portions are finished. The only two things which are remaining are thermo, basically thermal physics and thermodynamics and all of that, and waves, sound waves and string waves. So once that is done, the 11 standard syllabus is done, bacha. So here, first of all, understand this 4 is nothing but amplitude, and this 3 is also the amplitude of the other wave. First wave has no phase, second wave has pi by 3 phase. So that means this is your del phi. And we know to find the amplitude of the resulting wave, you need to use this formula. AR is equal to root of A1 square plus A2 square plus 2 times A1 A2 cos del phi. Correct, my warriors? Yep, you should use the resultant amplitude formula. Correct. Now just substitute all the values, you will get the answer. A1 is 4, so 4 square plus 3 square plus 2 into 4 into 3 into cos pi by 3, and 4 square is nothing but 16, 3 square is 9, and cos pi by 3 is 60, cos 60 is half into 2 is 1, so 1 into 4 into 3, 4 into 3 is nothing but 12. So I'll just put 12 over here, and that means this will be 16 plus 9, that's 25, 25 plus 12, that's the root of 37, which is approximately root of 36, which is nothing but 6. So hence the correct answer is B. Yep. Yes, Salva Kumar. Like I said, in nurture course, almost everything will be over very soon. Okay. I hope this is clear. Moving on to the next question. Two beams of light having intensities I and 4i, they interfere to produce a fringe pattern on the screen. They interfere to produce a fringe pattern on the screen. Phase difference between the two beams is 90 at A and 180 at B. The difference between the resulting intensities at A and B is interesting. Interesting. Let's see how many of you can do this. I think we need to use this formula. I'll just put it up on the top of the screen. IR is I1 plus I2 plus 2 times root I1 I2 cos del phi. So this is the formula that you have to use. So let's do this. So first let's talk about A and then B. So intensity of point A will be, the intensities are I and 4I. So I1 is I2 is 4I. Those are the intensities of interfering lights. So I plus 4I. Yes, Mahir, this is for 12th JEE, plus 2 times root of I into 4I into cos 90 degrees, which is cos pi by 2. So I'll just keep it like that. And IB will be I plus 4I plus 2 root I into 4I into cos pi, because second time at B the interference phase difference is 180 or pi radians. Now what has been asked? The difference of the intensities, that means IA minus IB. So when you subtract the two, can you not see clearly that I minus I is 0, 4I minus 4I also 0. So I think I'm just going to get 2 times of root I into 4I as common and cos pi by 2 minus cos pi. That's it. Now I can simplify this. Root of 4 is obviously 2 and root of I square is just I, and cos 90 is 0, cos 180 is minus 1. So minus minus is plus, so it will just become 4 times of I, which is option B, I suppose. Yes, Dakshin, it is B. Yeah, as simple as that. Then I done 4I. So the questions have been framed to confuse the audience, to confuse the students. But if you go systematically and if you know the correct formulas, you are going to get to the right answer. Correcto. That's it. That's correct answer. Option B. All right. Now also quick reminder, the last date for, basically the last entrance test for Ekalavya is coming up, so make sure you register for it. Ekalavya is the JEE advanced batch at Vedantu, absolutely free of cost, even including the registration, which has the best teachers, the best modules, the best test series, and the best preparation methodology for your JEE advanced preparation. Last year we had more than 1,500 selections from Vedantu alone. So that should be a boost for all of you, moral support, which will help you, have that faith in all of us, and make sure you register as soon as possible so that you clear the entrance and start attending the classes. Let's move on to the second part, and that is Young's double slit experiment. So I'm just going to go back to NCERT, and I feel you too should go back to your NCERT. Young's double slit experiment, and then we'll start questions on that, and then we'll go to diffraction, then questions on that, and then polarization, and then questions on that. I hope this is clear. Okay. Uh, well, I just, well, Ramya, I do know that Shimon sir has started the Tamil channel for all of you, the maths channel. Yes, he did mention about it, and I've also seen the channel. So I'm not sure exactly what you're asking about it, but yes, you should definitely go ahead and check it out. And whether I'm there in Ekalavya, last year I was there, but this year I don't have the bandwidth, Selva Kumar. But let me assure you, you have, in fact, teachers better than me only in Ekalavya. Okay, so don't worry about it. Let's get going. The next test I think is on 17th, Dakshin. Okay, it's on 17th. So in Ydse, you have two sources, basically slits. These sources will interfere on a screen and they produce a fringe. Fringe means band. Bright, dark band, and that is your Ydse setup. Okay, so this is what the setup looks like. You have two slits, they produce an interference pattern on the screen. But how do you create the two sources? By indirect way. So you can see this is your primary source, this is your primary source, these are your derived sources. Derived in the sense the light from this source will reach both the slits together, because of which the two sources will act coherent in nature. So all the derived sources are coherent because they will be derived from the same primary source. That's why they are coherent. And here you are going to see the pattern. You're going to see the pattern on the screen. That's what happens. Okay. Now, the path difference which is there for any point on the screen comes out to be, well, where did it go? It should be there somewhere. Yes, it's over here. It's S2P minus S1P, which is XD by D, which is actually better way to remember is approximately. I'll just put the same symbol, D sine theta, very easy way to remember. And when, if theta is small, if theta is small, then sine theta will be tan theta, and tan theta will be nothing but your x by d or y by d, whatever you want to call it. So this is a very, very important line right over here. Okay, so make sure you remember this. D sine theta. What is theta? Theta is the angular position, meaning if you are at any point over here, then this point P is going to make some angle with the perpendicular bisector. This theta is called as the angular position of the point. This is your angular position of that point, and x is the distance of the point from the origin or from the central maxima. So at point O, what do you get? The central maxima. I hope you remember that. Yep. So at point O, you get your central maxima. Maxima is same as the bright fringe. Basically, the bright fringe is what you get. That's the central maxima. I hope that is something which you remember. Sir, when will you say light chapter? This is light waves chapter, bacha. If you're talking about electromagnetic waves, that was done last time. And if you are talking about ray optics, that will be done next week. Hi Chinu, welcome aboard. Um, Ramya, in the Vedantu Tamil channel, it's only Shimon sir, nobody else. Yes, as of now. As of now, yes, only maths. Okay, cool. Then the width of the fringe. This is the width of the fringe. This is another formula which you need to remember. Beta, which is lambda d by d, which is the expression for the fringe width. Okay. Obviously, the fringe width will change if you change the distance between the slit and the screen, or the distance between the slits, or the wavelength of light, or you dip it in some medium. Okay, keep this in mind. All right. Now, this is also a very important line. The locus of the point P lying in the xy plane such that the path difference is constant is a hyperbola. Is a hyperbola. What it means is that imagine you have two sources, S1 and S2, and at some point, okay, at some point, let me just draw it over here, you find that you get constructive interference because the rays of the light, they meet constructively from S1 and S2. Now, the locus of all those points where the path difference, let's say it is some constant, I don't know, maybe lambda. If you draw that locus, it will look something like this. Look like something like this. This is basically a hyperbola. This is a hyperbola. This is what it means. So all the points which have the same path difference looks like a hyperbola, and when you go far away, the hyperbola almost becomes a straight line. That's what it is mentioned over here. If the distance is large, look over here, then compared to the fringe width, then it is almost a straight line. Is that understood? Is that okay? Is it entering your head? Okay, everybody clear till this point, my warriors? So only when the distance is small enough, you can see the curvature, but when the distance is large, then you see the hyperbola turning into almost like a straight line. Everybody remembers hyperbola from conic sections. Yeah, ellipse, hyperbola, circles, straight lines, all these are important conic section topics. Keep this in mind, my warriors. Okay, great. Now all this is fine, and this is something probably like a reading exercise. Yeah, this should be more like a reading exercise. Please do this. Okay. Um, so Selva Kumar, if you want JEE test, then yes, the best thing to do is the JEE crash course, exclusive JEE crash course, which has mains plus advanced level questions. You get assignments, not just that, practice tests plus all India level test where you can actually compare your scores with previous year JEE students. So the best thing I can assure you 100%, the best way to improve your rank and actually prepare for JEE mains plus advanced is the JEE crash course with test series. Okay. Yes, the Ekalavya entrance is free RLR entertainment and inventions. All right, moving ahead, and these are all just questions which you should definitely look after. And yep, so there we go. And this is also a very interesting example. So please go through this problem. Okay, so I'm marking that problem which you should definitely go through. Okay, so I hope now you are ready for solving some questions. Okay, so let's get going to some questions on the screen. And here is your first question coming up on your screen now. Salva Kumar, even if for 11th, well, you have the 11th Pro subscription. In 11th Pro subscription, you get something called as the Tattva modules. Tattva modules are separate for JEE and NEET. So they contain previous year mains, previous year advanced, plus practice questions for mains, practice questions for advanced, plus soil examples, plus theory revision for JEE. So it's an exclusive JEE booklet, plus you get JEE tests in the class, plus you get JEE assignments after every chapter. So that's what you can do. You can join the pro subscription and then make sure you get all those things without having to travel anywhere. Is that okay, Salva Kumar? Okay, so in Young's double slit experiment, the phase difference between the light waves reaching the third dark fringe from the central fringe will be how much? Let's see how many of you can get this. Very easy, but tricky question. Let's see. Many students are going to make mistake. I know that. But it's okay. Let's see how many of you can actually do this. The Young's double slit experiment, the phase difference between two waves reaching the third dark fringe from the central fringe will be, okay, some of you are saying C, Ramya saying C, interesting. So third dark fringe, okay, think. Well, in case you have forgotten, let me just show it to you. This is your screen, let's say. This is your central maxima. So at central maxima, the phase difference is 0 radian. Then you get your first maxima. You have 2 pi radian. So this is your first maxima. And then you get your second maxima and so on and so forth. So that is 4 pi, 4 pi radian. That is your second maxima and so on and so forth. Similarly, you have your minimas. So the first minima occurs over here. So that is at pi radian. That's your first minima or dark fringe. The next minima happens over here. This is your second minima, and it happens when the phase difference is 3 pi radians. And the third minima happens over here. This is your third minima, and that happens when the phase difference is 5 pi radians. The correct answer is option B. Okay, okay, I hope this is clear. Yep, Newton was close to finding the elixir of life. And yes, Dhaneshwar, okay, this is interesting, but I had heard about that he was going to research about, he turned into an alchemist towards the end of his life, but he died, and that's why he was not able to do any progress in chemistry. Else you would have a much fatter book in chemistry as well. So he spent his life throughout in probably, physics and astronomy and all of that. But yes, he also turned into philosopher and then alchemist. And okay, this is also interesting, Dhanishwar. So the correct answer is 5 pi. Another way of doing it is the phase difference is odd times pi. This odd number will start from 1, then 3, then 5. This is your first minima. This is your second minima. This is your third minima. So hence the correct answer will be 5 pi. I hope this is clear. Okay, I hope this is clear. Very good, very good, very good. Moving on to the next one. In Young's experiment, the distance between the two slits is 0.28 millimeter. Distance between the slits and the screen is 1.4 meter. Distance between central fringe and the third fringe is 0.9 centimeter. What is the wavelength of the light used? Let's see how many of you can do this. Pretty much straightforward. The question says that the distance between the central bright fringe, the third bright fringe is 0.9 centimeter. That means from the center till the third bright fringe. So if this is the center till the third maxima, that distance is 0.9 centimeter, and that distance is obviously 3 times the fringe width. 3 times the fringe width, because you will have 3 fringes: 0 to 1, 1 to 2, 2 to 3, 3 fringes. I hope this is clear. So that means 3 times of beta is equal to 0.9 centimeters. So that means into 10 to the power minus 2. So beta is nothing but lambda d by d. So that's the standard formula, is equal to 0.9 into 10 to the power minus 2. But if I want, I can do one thing. I can just get rid of those powers. I'm sorry, points, and write it as 9 into 10 to the power minus 3. So that 9 and 3 goes. So lambda will be equal to small d by capital D. 9 by 3 is 3. So 3 into 10 to the power minus 3. So just substitute the values. Small d is 0.28. So 0.28 is 28 into 10 to the power minus 5 meters. Millimeter is 10 to the power minus 3, and those two decimals. So it will become 10 to the power minus 5. And this is 1.4, which I can write as 14 into 10 to the power minus 1 into 3 into 10 to the power minus 3. 14 and 28 goes 2 times. 2 3s are 6. So 6 into, I will have 10 to the power minus 7 meters, which is 6 into 10. Sorry, my bad. 1 second. Yep. So that will be nothing but 6. Anyways, you can guess the answer now. It will be 6,000 into 10 to the power minus 10 meters. This is nothing but Armstrong. So that's why the answer is B. Yep. So the Doppler effect will come in waves. Waves, light waves chapter, Ankit. It's like I just showed you, it's in NCERT in light waves, wave optics chapter. It's not there anywhere else. Sound Doppler effect is there in 11th standard waves chapter. It's that 11th standard. But in 12th standard, it only will come in wave optics, nowhere else. Okay, great. Moving on to the next one. In an interference experiment, the third fringe is obtained at a point on the screen where the light is of wavelength 700 nanometers. What should be the wavelength of light source so that you get fifth fringe at the exact same point? So at some point, you're getting third bright fringe when the light is of 700 nanometers. What should you do to get fifth fringe of some other color? Yes, Selva Kumar, you don't need to care about the powers. So here is the logic. See, you are getting the third fringe of color 1. Third fringe means 3 fringes, 3 fringe widths. So the 3 fringe widths of light 1 should be equal to the 5 fringes of color 2. This is the equation, so that you get it at the same point. So same point, that's what it means. So converting words into equation, that's what I have done. 3 beta 1 is 5 beta 2. Now what do? Beta 1 is lambda 1 d by d, and beta 2 will be lambda 2 capital D by d. Why d and d are same? Because it's the same setup, only color changes. That's why capital D and small d are same. So that's it. You want to find lambda 2, right? So it will be 3 by 5 times lambda 1. So 3 by 5 times of lambda 1. Lambda 1 is 700 nanometers. So 5, and this will go 140. 140 into 3, that's 420 nanometers, which is option D, I suppose. Very good. Very good. Okay, Kamal Raj, if you're a 11th standard student and you want to start your preparation, I will suggest you one simple thing, bacha. There is a lecture of mine, a session of mine where I had told how do you cover backlogs and how to start your preparation for 11th JEE and then continue into 12th. There's a lecture of that. Just go to our channel. In our channel only it's there. Just go behind how to cover backlogs 11th standard Shreyas sir. You will find that class. If you don't find it, don't worry. Just leave a comment after the video ends. I will reply to your comment with the video link. I hope that is Gela Manvit, you should watch the Nurture series, or you should definitely watch the previous year series where I have explained what is a wave, what is the different concepts and terminologies in a wave, because this is right now a 12th standard chapter. Okay. Yep. Okay. Yes, very true, Selva Kumar. That's why we started English channel. Imagine studying all these things in English or in Hindi. I don't know. How do you guys do that? Especially when you're in English medium. Okay. So there is a reason why you guys join English medium. And then if you study in Hindi or English, that means you're probably deceiving your entire understanding. And then obviously your brain is confused because in school you're studying in English, the books are in English, and then you're studying for JEE in Hindi or English. That's obviously going to confuse your brain and understanding levels. So you should make sure that you study in the same language to maintain consistency, else you start getting confused. The thought processes which develop in your brain also get confused. Okay. The maximum number of possible interference maxima for a slit separation equal to thrice the wavelength in Young's double slit experiment is. Interesting question. How to get practice questions? Gela Manvit, one easy way for free. Watch all our YouTube classes and download all the PDFs from our Telegram group. That way you'll get all practice questions of all the sessions. Number two, if you want more, obviously you want, then you join the pro subscription. There you get assignments, test series, Tattva material, class notes, class PDFs, everything. So that will be extensive. So I give you both the options. Yes, Shyam, you can definitely start. And how do you start that? Well, leave a comment or ping me on my Instagram handle, Shyam Sundar. I'll definitely tell you how you can start your mains plus advanced preparation for class 11 standard. Okay, I'll help you with that. Okay, so the maximum number of possible interference maxima for a single slit separation equal to the for slit separation, sorry, equal to thrice the wavelength. The meaning of this statement, slit separation equal to thrice the wavelength, meaning small d is thrice lambda. Small d is thrice lambda. Now you guys know that if this is your screen, and these are your two sources, then exactly at the center, your path difference delta x is equal to 0. Agree? Because both the waves reach simultaneously. There is no difference in the wave distances that they have traveled. Hello Gulshan, hello online study. Thank you Bachalo for all your love. Now, as you go away, think about it. As you go over here, you will see one wave has to travel more. Delta x increases. The difference in the path length increases. As you go even further, eventually at infinity, so when you reach infinity, you will see delta x tends to, look at that, one wave has to travel exactly this much distance, which is d. Delta x tends to d. Is that making sense? Delta x, because one wave, the one on the top, has to travel d distance less. So it will tend towards d when the waves have to meet at infinity. This is at infinity, correct? So at infinity, the path difference does not tend to infinity, it tends to d. This is the concept. Now start solving the question. Okay, let me make myself small. So what you need to do is start on the screen. Okay, and start. Oh, sorry guys, 1 second. I need to learn how to draw straight lines. Okay, you start from 0 lambda. That's what the first path difference will be. The next will be 1 lambda. Remember, delta x increases, I just mentioned about it. Then you will also have 2 lambda, and at infinity means no, you will tend towards 3 lambda, but you will never, tending means not equal to, you will get close to it, but not be equal to 3 lambda. Now why 1 lambda and 2 lambda I'm talking about? Because I'm talking about maxima. Maximas are basically constructive interference. These are all maximas. So count the number of maximas. 1, 2, 3, but there will be more down. Don't forget the ones which are below 1 lambda and 2 lambda. So how many maximas are there? You can see 5 maximas are there. 5 maximas are there. 2 below, 2 on the top, and the one at the center. So hence the correct answer is B option, which is 5. Is that understood? So remember, always start from 0 and keep on increasing. 1 lambda, 2 lambda, n lambda is for maximas. So for maximas, remember, it is always n times of lambda. For minimas, it is odd lambda by 2. So how many such lambdas will be there on the screen? There will be 5 such maximas on the screen. Is that clear, my warriors? Is this understood? This is a very important question. This has been asked in different ways in JEE Mains. Okay, you should know how to count the number of maximas and minimas. If I ask you how many minimas are there in this question, if I ask you how many minimas are there in the question, then what will your answer be? Let's see how many of you can get this. Think, odd lambda by 2, that means 0.5 lambda, okay, 0.5 lambda, then you'll have 1.5 lambda, then you will also have 2.5 lambda on the top, correct? And same thing over here, 0.5, 1.5 and 2.5. So you'll have 0.5 lambda, 1.5 lambda and 2.5 lambda. What are these? These are all minimas. So how many minimas are there? Count. There is no central minima. 3 on the top, 3 below. So totally 6 minimas are there. If the question was on minimas, then your answer would have been 6. I hope this is clear. Selva Kumar, that will definitely give you till JEE mains level. Yeah, till JEE mains level. Yeah, for sure. In fact, you are also touching JEE advanced. In fact, you are also touching JEE advanced. Okay, moving on to the next one. Very interesting question. The maximum intensity in Ydse setup is I. The distance, or I naught, actually this was I naught, because you can see in the options I naught is there. So this is supposed to be I naught. Oops, 1 second. Let me make this as I naught. Okay. The distance between the slits is 5 lambda. Lambda is the wavelength of the light. What will be the intensity of the light in front of one of the slits on the screen at a distance d, which is equal to 10d? Intensity of the light in front of one of the slits. Meaning, let's just draw the diagram. Okay, first let me just draw this straight line to the screen, of course. So the screen is going to be something like this. This is your screen, guys. Oops, my bad. Okay, so really, okay, there we go. Where is it? Yes, here. Okay, so this is your screen, and these are your slits. This is your slit S1 and this is your slit S2. The distance between them is obviously mentioned, and that distance is nothing but small d, and in front of it, that means over here, you are right over here. This is not the center is over here. Keep this in mind. In fact, if you measure the angular position, you will realize this is your perpendicular bisector and this is your theta, and if this is theta, and this is going to be d by 2 because you are exactly in front of one of the slits. So this is the perpendicular bisector. Remember, this is perpendicular bisector. So that distance has been divided into halves, d by 2, d by 2. You are over here. Is that clear, my warriors? So the waves of light are coming like this. One wave is coming, oops, 1 second. Now one wave is coming like this probably. Okay, let me just show it over here. One wave is coming like this and the other wave is coming right from here. Okay, they are meeting at this point. Is that situation clear now to all of you? So this is the situation. Now let's start solving the question. The question is, what will be the intensity of light? Okay, let's start doing this question. First things first. To find intensity, I need to find out the phase difference. Without phase difference, I cannot find the intensity, correct? Because you have to use the formula I max into cos square phi by 2 in case you have forgotten about it. To find phase difference, you need part difference, and the part difference formula delta x happens to be d sine theta, and I had told you sine theta is tan theta, and tan theta is nothing but opposite side by the adjacent side. You can see that very clearly from this diagram. In that right angle triangle, opposite to theta, you have the side d by 2, and the adjacent side, the one below, that's the distance between the source and the slits and the screen. This is the screen, of course, right? So that's capital D. So that will be divided by capital D. So this will be d square by 2d. But I think I know the value of capital D. Capital D is 10d. So this will become d square by 2 into 10 small d, which is d by 20. Now d is also given to be 5 lambda. Interesting. So that is 5 lambda by 20. So this will be lambda by 4. See if you guys are getting it. You're getting it as lambda by 4. So that's part difference. Once you get part difference, you are going to move to phase difference. And the formula for phase difference is 2 pi by lambda into delta x. I hope you remember that. Chalo, let's substitute everything. So 2 pi by lambda into delta x. What is delta x? What is delta x? It is lambda by 4. So lambda by 4. So it will become pi by 2 radians. Once I get del phi, the last step is intensity. Intensity will be maximum intensity into cos square del phi by 2. That's the formula which I had told you, I had marked you, I had highlighted it in the NCERT. Imax, what is the maximum intensity? Maximum intensity is clearly mentioned in the first line of the statement of the question. It is I naught. And cos square del phi, what is del phi? Del phi is pi by 2 divided by 2. So basically it will be I naught cos square pi by 4, which is nothing but 45 degrees. And 45 degrees cos is 1 by root 2. So it will be 1 by root 2 square, which finally will give me I naught by 2, which is nothing but option A. That's the answer. What a brilliant question it is. Did you love it? And if you loved it, yes, go smash the like button down there if you need more questions like this. This is a brilliant question. So what are the steps involved? First, drawing the diagram. Second, understanding the geometry at the point P as at a distance of d by 2 from the center. Next, finding part difference, the one in blue. Then finding phase difference, the one in green. And lastly, using intensity formula to find the net intensity. Brilliant question. Okay, so let's quickly move to the diffraction formulas. Single slit experiment. Please open up your NCERTs, my warriors, quickly. Okay, let's have a look at the NCERT right over here. Okay, there we go. One second, my warriors. One second. Okay, let me just open it up. There you go. Yes, there we go. Yeah, so there we go. Yes. Salakumar, leave a message after the session ends, and also if you want, you can message me on Instagram. I'll definitely reply to you personally. Okay, Bacha? I hope, Salva, that is clear. Now, very important line, diffraction is a general wave characteristic. It is exhibited by all kinds of waves. Very important. And the wavelength is much smaller than the dimensions of most of the obstacles. That's why we do not encounter diffraction of light in everyday life. So only when the wavelength of light or wavelength of the wave matches with the dimensions of the slit, only then you see the diffraction effects being very profound. So the wavelength of light and the slit width, etc., should be very similar, then you see more diffraction. What is diffraction? Diffraction is bending of light. It's basically, when you have a slit, only one slit, not two slits, only one slit, and light passes through it, you will see the light will spread and will produce interference pattern. So that is your diffraction. Now, the only diffraction that we need to know is the single slit and the aperture related diffraction formulas. So if you take only one slit, still you will get interference pattern. Generally in Ydse you have two slits, and you know that yes, you have two slits, two sources, and then yes, both the slits will produce waves and they will interfere on the screen. But when you have single slit, how does it produce interference pattern? The answer for that is, even in a single slit, you have multiple sources even in that width of the slit. So just think of it this way. If this is your opening, this is your slit, okay, these points are going to act like sources, and these sources are definitely then going to produce wavelets, something like this, and they are going to produce interference, and that's basically your single slit interference pattern. Okay, I hope this is clear. Now, going ahead, the only few things that you need to know right over here. Okay, so going down over here. Yes, so for small angles, what's the part difference? This is one formula which you need to know. Okay, yes, this is one thing. Wait a minute, and then going down. Yes, over here. Yeah. Okay, so wait a minute. I will give you the formula the better way. Okay, I think it is rare over here. One can similarly show the intensity is 0 for theta is equal to, okay, they have mentioned it somewhere in between, and let me just highlight it for you. One can similarly show that the intensity is 0 for theta is equal to n lambda by a, or basically sine theta or a sine theta is equal to n lambda, where n is any integer except 0, of course. Okay, this is fine. This is something which you need to know. And going down, um, similarly for maxima, it is at n plus 1 to lambda by a. Okay, now the better way of representing all of this is the minima. For minima, I'll just mention it over here. So for minima, you're going to use, okay, a sine theta is equal to n lambda. This is the formula you're going to use, and sine theta can be approximately equal to theta for small angles. This is only for small angles. This is for minima. For maxima, what will you do? Instead of n, you're going to use the number odd. So for maxima, I'm just going to mention it over here. This will avoid all the confusion. For maxima, it is a sine theta is equal to odd times lambda by 2. This is the formula which you're going to use for maxima. For single slit diffraction, what is A? In case you're wondering, it's the width of the slit. It's the width of one single slit. Look at this experiment. This is the slit. This is the width of that slit over here. The width of the slit is basically A. Keep this in mind. And you can see the interference patterns out here. This is the central fringe, and you can see this is your first minima. This is your first minima right over here. This is your first minima, and you can also then conclude that the width of the central fringe is this much. This is the width of the central fringe. Okay, you can see this is the width of the central fringe right over here, from first minima on the top to the first minima below over there. All these are important things. Okay, now this is a important reading paragraph. Read this. This is the reading exercise. Please read through this. I'm marking it over here. And going ahead, yes, the difference between interference of two slits and interference of single slit has been mentioned in these three points. So please go through it. Very, very important. Very, very important. I'm highlighting it. The difference between single slit and double slit. Okay. Now, yep, this is all fine. Now, how do you see single slit using blades? This is something which you can do at home. Resolving power, very, very important formula. Okay, so I'm just going to highlight this. So resolving power of telescopes, very important formula. Then resolving power of microscopes. Where is it? Yep, I think it's below. Yep, yes, it's here. One, yes, the resolving limit of microscope. And this product n sine beta is called numerical aperture. This is also important. This is for microscope. These are the only two things which you need to remember for telescope and microscope. Now, what are these two things? See, this number R0 is telling you the minimum distance between two objects which should be there so that you can see them clearly in a telescope. Imagine you are seeing anything through a telescope and you are not able to distinguish between the two objects. That's because of the light which is coming from those heavenly celestial bodies is getting diffracted through the aperture of the telescope, And that's the reason why the light is spreading and it is creating an interference with other images of other bodies. So if you want to see the two objects distinctly, the minimum separation between them, okay, is given right over here. This is for telescope. It's mentioned right over here. Okay, so very important formula. This is for telescope. 0.61 times lambda by a. This is the angular separation between the two objects so that you can see them clearly. What is a? It is the aperture. What is lambda? The wavelength of the light. A is the, yeah, this is very important. Great. Similarly, for microscope, the formula looks very similar. The distance between the two objects so that you can see them very clearly is mentioned over here, 1.22 lambda by 2n sine beta. What is n? Refractive index of the medium in which the sample is kept. Okay, this is something which again you should definitely know. Keep this in mind. But the product n sine beta is called numerical aperture and it is generally given to you. Keep these formulas in mind. And important thing, resolving power is just reciprocal of the resolving distance or the minimum separation between them. So in case you are asked a question on resolving power, just flip this formula. That's a resolving power. That's all you should know. Okay, so keeping this in mind, the last thing that you should know is about Fresnel's distance, and that Fresnel's distance is that minimum distance after which the diffraction effects become significant. Meaning, see, you have light which is going through a slit, let's say over here. Okay, these are the light rays which are entering through a slit and they are diffracting. Now, when you're close by, you will probably get a narrow fringe. When you are a little bit far away, you will get a bigger bright fringe. There comes a point where the central fringe, this is your central fringe, becomes as wide as your slit. This is your central fringe becomes as wide as your slit. After that, if you go far away from that particular point, then you will see the central fringe will be wider and then you will feel the diffraction effects being prominent. Now you will feel that yes, diffraction is happening because the width of the slit which is perceived on the screen is wider. Slit can be 1 millimeter wide, but if the image is 1 millimeter or less, you will be like, oh, it's not getting bent. But if the image on the screen, the central fringe on the screen is wider, then you will feel the light is spreading. So that minimum distance after which you get that perception that the light is spreading is called as Fresnel's distance, and that is a square by lambda. What is a? The width of the slit. What is lambda? The wavelength of the light. As simple as that. Okay, so I hope this is clear, my warriors. This is a basically. Okay, so this is a, nothing else. Keep all these things in mind. All right, so we'll go to polarization in a bit, but let's start solving some questions now. Okay, so here's your first question coming up on your screen. Start solving this. If you observe that the single slit diffraction with wavelength lambda and width e, the width of the central maxima is 2 theta. On decreasing the slit width for the same lambda, what do you think will happen? Will theta increase? Will it remain same? Will it decrease? Or it increases or decreases depending on the intensity of the light? Is easy questions of JEE Advanced enough for JEE Mains? Dakshin, it's not the right strategy. I know when you prepare for advanced, you prepare for mains indirectly, but when you want to score really good marks, then just solving advanced questions does not help you for mains, because the mains portions are slightly different, number one. Number two, the pattern of the questions is different. Number of questions is different. Difficulty being different, speed, accuracy matters more than your correctness of the questions over there. Even if you solve few questions in advance, still you can really do well. But in mains, if you solve just few questions, you may not do well. You have to solve many questions. So it's a whole different ball game. Yep. Yes, Farzan. It is almost. Yes. Maybe if you find few topics here and there which are not there, you will find it in Zero to Hero series or something like that. Okay. So how do you solve this question? First of all, what is angular width of the central maxima? Angular width of the central maxima is 2 theta, meaning this is where you get the first minima. This is your central maxima, and this is again your first minima. This is the best way to represent the central fringe or the central fringe width, angular width. Now, out of that 2 theta, only this much is theta. Fair enough. So what is theta? I think I just gave you a formula. A sine theta. So for first minima, n will be 1, will be equal into lambda. So sine theta is approximately theta. Therefore, theta is equal to lambda by A. Therefore, the angular width, which is basically 2 theta, will be 2 times lambda by A. Now in the question, it is mentioned if the width of the slit is decreased. It's mentioned decreasing the slit width. That means A is reduced. What will happen to the angular width? Obviously, it is going to increase. Hence, the answer is option A. Done, done, done. You can see that option A is correct. Understood? Very easy. So, angular width will be 2 times lambda by A because the maxima will be spread above and below. So the angle wise width will be 2 theta. Theta is the angular position of the first minima, and for that I've used the formula A sine theta is n lambda, where n is 1 because you want first minima. That's it. Solve it, you'll get the answer. Moving on to the next one. Great. So the direction of the first secondary maxima in a single slit diffraction pattern is given by which correct relationship? Very interesting question. The direction of the first secondary maxima. First secondary maxima, be careful about it. Okay, the first secondary maxima, where do you think will be the correct angular position? What's the correct relationship for that? So if this is your screen, hi Umesh, welcome aboard. And this is your slit, of course. Okay, this is your slit. Then you will get the first maxima somewhere over here. Question is, what will this theta be? Now we know for maxima the formula is A sine theta is odd times lambda by 2. That's what it is. It's odd times lambda by 2, right? So now think, what is that odd number? That odd number, what will be the odd numbers? The first odd number is 1. The first odd number is going to be 1, right? So that's one thing. The next odd number is going to be 3. This is where you are going to get your first maximum. Think about it. This is where you're going to get your first maximum. Is that clear? Is that making sense to all of you, my warriors? Odd times lambda by 2, that's where you're going to get your first maxima. The question is the first secondary maximum. What are you going to do? Why not minus 1? Yes, you can go to minus 1 also. You can go to the minus 1 also. Yep. So what will happen? You should get it as A sine theta is equal to 1 times lambda by 2. The secondary maxima. The first maxima, where are you going to get? See, this is your central maxima. This is your central maxima. The rest all are secondary maximas. These are your different other maximas. This is not your primary maximas. So you're going to get it at 1 lambda by 2. So, I think the answer marked over here is wrong. Ignore that. So the correct answer should have been A sine theta is equal to lambda by 2. Be careful, guys. Is that okay? You can also write it as minus lambda by 2. That will also be okay. In fact, you can have both plus or minus. Doesn't really matter. Is that okay? Is that making sense? Okay, cool. Moving ahead. Resolving power of a telescope whose lens has a diameter of this much meter. The diameter is so much, wavelength is this much. What do you think is the resolving power? Now, I had clearly mentioned one thing. Resolving power of a telescope is 1 upon the or reciprocal of the resolving limit. Resolving limit as in what is the minimum separation between the two objects. The minimum separation between the two objects that was given by the angular position. The angular position between the two objects, if you remember correctly, that was given by 1.22 lambda by A. This was delta theta's formula. Delta theta formula. Delta theta is the angular separation between the two objects from a telescope. So if you have a telescope like this will have some aperture. This is A. Then the two objects, two stars, will subtend some angle over here. If the angle between them is at least delta theta, then you will see distinct images via the telescope. If you see it from here, if you see it from here, you will see two distinct images. If it is lesser than that, you are going to see overlapping of images. Okay, so just rearrange this. You are going to see A divided by 1.22 lambda. Now just solve the question by substituting the values. A is 1.22 meters. It's given. This divided by 1.22 into lambda, which is 5000 Armstrong. Armstrong is 10 to the power minus 10. 1.22 gets cancelled, so it will become 1 by 5 into 10 to the power minus 7, so it will become 10 to the power 7. 1 by 5 is 0.2 into 10 to the power 7, which is 2 into 10 to the power 6. Yes. Is this 12th class formula? Yes, Jat Sandeep, it is. It is 12th class formula, wave optics. It's there in wave optics term 2 syllabus. Okay, it's there in NCERT's 2. Okay, that's the answer. 2 into 10 to the power 6. So if you, what are you seeing? If you know the formulas, you can get it very easily, else you're going to struggle with it. These questions are very straightforward. It looks difficult, it looks confusing, but when you get a hang of it, trust me, it's simple. And if you still need help, watch my lecture on light waves for, you know, diffraction. I have explained in detail the entire process of resolution, just resolved, resolving power, everything in detail. Please watch it. Take away batch will start Jat Sandeep towards the end of Jan. Okay, so now moving ahead, my warriors, and let's see what do we have. Okay, just 1 second. Yeah. So yes, let's go to polarization. Quickly, let's mark what are the different things in NCERT with regards to polarization. I'm opening up NCERT. Please open up your NCERT quickly so that we can start marking the important pointers in polarization. Now, what is meaning of polarization? See, only transverse waves can be polarized. As in, if you take a wave on a string and you pass it through a slit, then if the slit is aligned with the oscillations of the wave, then the entire wave will pass through the slit. But if you are making the string vibrate in a direction which is in some other direction as compared to the slit through which the string is passing, then the wave will not pass properly. You can see a part of it will just get chopped off. So that phenomena can only happen in transverse waves, where a part of the wave gets chopped off when you pass it through slits. But if you have sound is a longitudinal wave, the vibrations are in and out, so it doesn't matter what the orientation of the slot is, you are going to see the sound propagate no matter how you are going to orient that slit. So that is polarization, and it can only happen in transverse waves. Keep this in mind. Okay, that's what has been explained at the start. And then going down, linearly polarized waves described over here. The displacement of each point on the string is always at right angles to the direction of propagation of wave. The plane of vibration of a string, if it is changed randomly, if you change it once like this, once you're oscillating it like this, then it is unpolarized. Unpolarized means sometimes electric field is oscillating like this, sometimes like this, sometimes like that. Remember, light is an electromagnetic wave. Okay, so moving ahead. Um, yeah, so what is a Polaroid? Polaroid is a material which allows only certain planes to pass through it. So if the oscillations are in a certain plane, only those you can say those oscillations can pass through those materials. They are called as Polaroids. So a Polaroid is basically a long chain of molecules aligned in a particular direction. Only those vectors in a particular direction get absorbed, other things just get passed. So let's get going over here. And what is the pass axis? Pass axis means only those things which pass through the Polaroid. Those are called as the pass axis. The other things which are not in the direction of pass axis, they will get cut out, they get chopped out. Remember that. Yes. Difference between polarization and polarized. Polarization is a process. Polarized is nothing but a term used to a light which has passed through a polarizer or through a Polaroid and it has got polarized. So that's the difference, chat. Okay, I hope this is clear. Now, a very interesting thing over here. You can see there are two Polaroids. Two Polaroids. So if you pass light through one polarizer or one Polaroid, you will see that this is okay. Let me explain this to you in a very simple manner. This is one Polaroid, and this is your unpolarized light. This is your unpolarized light. This is unpolarized. Okay, let's say it has intensity of I naught. If it passes through a Polaroid, if it passes through a Polaroid, something like this is your Polaroid, then what will come out of it? You are going to get a polarized light. Only those light vectors which are in the direction of that polarizing plane, only those fields will get passed on the other side. Rest everything will get absorbed. This intensity will be exactly half of the initial intensity. This will be exactly half of the initial intensity. Half of the light will get absorbed, only half of the light will go out. This is when unpolarized light comes out, it becomes polarized like this. Very, very important. And then you have the extended law over here. If you have polarized light, let's say of intensity I, so right now this is polarized, and then you pass it through a Polaroid. You pass it through a Polaroid which is at an angle, okay, which is at an angle, okay, let's say theta. If this is theta, then the light which will come out of it will be only a component of it. Only that particular component will come out, and that intensity will be I cos square theta. This is called as Malu's law. This is called as Malu's law. Keep this in mind. So if you remember this part, that's it. You are going to remember the rest of it. Okay, this explains the entire thing. This is Malu's law. It's all mentioned over here. Okay, very, very important. So Polaroids can be used to control intensity in sunglasses, window panes, etc. So please read through these application part of all of that. That's all that is mentioned over here. So moving ahead. So polarizing by scattering. This is a very, very important diagram. So when the light which comes out of from sun, which is unpolarized, and it falls on reflecting surfaces, you will see the reflected light gets polarized, and that angle of incidence for which the light which is reflected gets completely polarized is called as Brewster's angle. I'll repeat, it is called as Brewster's angle. So when light which is unpolarized, it falls on a surface and it gets reflected, it gets partially polarized. But at a particular angle, if you incident it, then it gets completely polarized. That is basically called as the Brewster's angle. So very, very important. These I just put over here. The oscillating, yes, so two directions, refracted wave, the okay. The reflected light is therefore almost linearly polarized as shown in the figure over here. Okay, but when the unpolarized light is incident on a boundary between the two transparent media, the light ray gets completely polarized. Okay, when it gets totally polarized, when that angle is equal to the Brewster's angle. That Brewster's angle formula is this one. What is the Brewster's angle formula? Mu is equal to tan of angle of incidence. This is your Brewster's angle, and this is called as your Brewster's law. So when your angle of incidence tan is mu, refractive index, then the entire light which is reflected, the entire light which is reflected over here will get completely polarized. That's something which you need to know. So, okay, so keep this in mind. All right, so that's all that is there, and the rest of the things are plain and simple. Okay, so yes, you should definitely go through the summary part of it and also go through points to ponder later. Okay, so that's what is there in this chapter. Please download the PDF later on from the Telegram channel. I'll be posting it. All my handwritten notes and all the highlighted stuff will be there. For now, let's solve the questions on polarized light. Here's your first question. There are two nickels. Nickels is a polarizer or Polaroid, which are oriented with their principal axis, making an angle 60 degrees. So the percentage of incident unpolarized light which passes through the system is how much? Think about it. Good evening, Anchal. Bharat, I'm perfectly fine now. Much better. Yes, I'm not feeling that pain in my throat anymore. So looks like I should be well now. Yep. Yep. Will I take NCERT Underline for all the sessions, Roshni? Well, my first priority will be to complete JEE. Now, the thing with these two chapters was that I completed these two chapters like last month and even before that itself. So I'm doing the NCERT Underline plus practice problems because it will act like a revision for all of you. That's the reason why I'm doing it. Okay, so for other chapters, first I'll be doing the syllabus, completing the syllabus, and then I'll be probably doing some NCERT series. But if you want me to give the NCERT underline there and there itself, then I can do that as well. Okay, hi Kavya, welcome aboard. Yes, so let's see how can we do this. Two Polaroids are at 60 degrees with respect to each other. Let's solve this question. So the first Polaroid is like this, and the next Polaroid is at 60 degrees with respect to it. This is at 60 degrees with respect to it. So when unpolarized light is going to fall, this is unpolarized light. This will have some intensity, let's say I. When it comes out of it, the intensity will straight away reduce to half. Remember, it becomes polarized. It will become I by 2. When this polarized light passes through other polarizer, only a component of it will go out by Malu's law. So I by 2's cos square 60 will pass. Cos 60 is half. So it will become 1 by 4. So it will basically become I by 8. According to the question, what is the percentage which passes through the system? Percentage which passes through the system is how much passes upon how much was incident, the whole thing into 100, which is basically 100 by 8. 100 by 8 is obviously 12.5%. That's it. That's option C. And no, it is not D, it is option C. Done, done or done. It's not 37.5. How much percentage passes through the system? So first half of it gets cancelled. Then out of that half, only the cos square 60 intensity gets passed on through the second polarizer. So only 1/8 will pass. 1/8 of basically 100 is 12.5%. That's the answer. Okay, this is a beautiful question. Let's see how many of you can do this. But a small addition over here. Well, I think this angle over here, this is 30 degrees with the vertical. Read the question carefully. You can see on top and bottom, there are pairs of polarizers. So on the top, you will have one polarizer, the next is below. Their angles of pass with respect to vertical or horizontal are mentioned and they are shown in the dotted line. The dotted lines show the pass angle or the pass plane. That means if light is polarized and it is aligned with the dotted line, it will pass. If it is not, then a part of it will only pass depending on the angle. So the question is, if you take each pair, you pass unpolarized light, then which pair will pass the maximum light? Which pair will pass the least light? Starting with the greatest first. Which will pass the most amount? Which will pass the least amount? Think carefully. Very interesting question. Okay. Now, if you look at the first pair, calculate, see the relative angle. See, both of them are aligned, right? If both of them are aligned, then whatever light passes through the first will also pass through the second. But if one is like this and the other is perpendicular to it, then nothing will pass. Nothing will pass. Because from the first, the light which will be coming out will be having the plane polarization in one direction. The second Polaroid will be perpendicular and cos 90 is 0. So 0 intensity. So if they are perpendicular, that means the relative angle is going to matter. So let's try this out. For the first question, if you measure the angles with respect to vertical, just do that. It's not that difficult. This is 60 degrees. This is 30 degrees. Correct? This is 60. Oops, sorry, my bad. I just need to, yep, just check this. Oh yeah, that's correct. Oh, I'm sorry. This was correct. This is 60 degrees and this is 30 degrees. Don't you see the relative angle? The relative angle is actually 0 degrees. If relative angle is 0 degrees, so maximum amount will pass. This will be the max. I hope you can see that. So the first one will pass the maximum amount. And since it says greatest should be first, so I doubt if D option will be correct. In fact, D option has fourth number first, which I think should be wrong, because if both of them are aligned, there's maximum. They both are aligned. Okay, so that's something which you should remember. Next, for the fourth one, if you notice, in fact, what's happening is that this is 30, so this is 30, then this is also 30 degrees. Now, the first polarizer is at 30 degrees with the horizontal, next polarizer is at 60 degrees with the horizontal. So what is the relative angle between them? The relative angle between them, always compare it with the same thing. Compare it with the same thing, 60 degrees with horizontal, 30 degrees with horizontal. So the relative angle is 60 minus 30, which is nothing but 30 degrees. Okay, so the relative angle is 30 degrees in this case. Okay. In the second case, what is happening? Okay, observe carefully now. Observe carefully. In the second case, what is happening? Now, this is 60. So I believe if I drop a perpendicular like this, now this will be 30 degrees. Now, the planes, the dotted lines, for the top one is on the left side 30 degree. For the bottom one, it is right side 30 degree. The top one is left side 30 and this is right side 30. So what is the relative angle? The relative angle is basically 60 degrees. I hope you can see that. Relative angle is 60 degrees. Interesting. The only thing remaining is the third one. Let's do that as well. So for that one, okay, so 30, 30, and if that is 60, obviously this is 30 degrees. This is 30 degrees. So the second polarizer is 30 degrees to the right of the vertical. The first polarizer is actually speaking 60 degrees to the left of the vertical. So the angle between the two dotted lines, what is the relative angle between them? What is the relative angle between them? Isn't it 90 degrees? And if it is 90, that's it. It's going to be blocked. It's going to be blocked. And in fact, that intensity will be minimum. In fact, it will be 0. So third one will be the least. First one will be the most. I can see only one such option like that. Third option is the least. This is most. So this is minimum. Okay, I hope you can see that. And over here, the first one is basically the maximum. The other two, fourth and then second. Why fourth is next? Because the angle is 30. So when the angle is small, you are nearly aligned. When the angle increases and becomes more towards 90, it gets blocked. So when it's 30 degrees, more light will pass. When it's 60, even lesser light will pass, because the intensity formula is I naught cos square theta. So if theta increases, cos decreases. The intensity which passes will also decrease. So as theta increases, intensity decreases. Keep this in mind. Hence option D will be correct. Okay, I hope this is clear. Very interesting question, my warriors. All right, beautiful analysis, amazing question on interpreting and the geometry aspect out of it. Now I have some homework questions for all of you. Roshan, Kishore, it's evening and I'm not sure in which part of the world you are in. This is your first homework question. Please solve this. This is your second homework question. solve this and put up the answers in the comment section definitely. And this is your third homework question. Okay, and this is your fourth homework question. If you practice this, you will have a peaceful sleep. You will have that peace of mind, that satisfaction that yes, I have completed a task today. Else, you will have that feeling of incompleteness. And if you want more sessions, you want more practice, you want more test series, you have the JEE crash course, which has 90 live classes. I'll be also there in the crash course for a few sessions, but you have amazing teachers who are going to take care of each of those dedicated topics. And you have 10 full syllabus and 10 part tests, along with all India mock tests where you can compare your ranks with previous year students. Not just that, you also get you know uh, assignments, you also get PDFs, notes, and also the recordings of all the classes in case you miss any of these things. This is the crash course which has just started on Monday. You can enroll yourself. And yes, remember one thing, this crash course is in English. The original price was 20,000, but on offer it's going out for 10,000 rupees. But since you're watching this class, it's more off. You get 1,000 rupees off on that, and that's for 9,000 rupees. To join it, there is a link in the description box below. Make sure you go ahead and check it out. Okay, I'll be hoping to see all of you, all my lovely warriors who are on Enthuse on the Vedantu platform in the JEE crash course as well. You're going to find me out there as well. Thank you very much for tuning in. It was indeed a great class. We have completed one shot practice problems, NCERT Underline important formulas of light waves, which includes Hygen's principle, interference, Ydse, polarization, and diffraction. Now I'm going to start ray optics next week. I hope you will be there. Make sure your friends are also there. Tell them that Shreyas sir is going to start ray optics, and we are going to complete it in big lectures in less number of classes. I don't want to drag it for a long time. Okay? Yeah, I hope this is clear. Let's get going. And thank you for tuning in. How was my um, my research experience? I have not done PhD. I have done the research. That's in different way. Okay, so if you were to do PhD, yes, please go ahead with it. Selva Kumar, just ping me on my Instagram. I'll definitely help you out and tell you everything about it. I know you want to talk to me and you want to get to know a lot of things. Ping me on Shreyas_Vedantu. All right. Thank you, Ankit. Thank you. Thank you so much. And Ankit, glad you made notes. Take care, Harni. And Kunal, yes, if you want to ask anything, please do let me know, bacha. You can also leave it in the comment section below. Thank you, Dakshin. Welcome aboard. Can I crack JEE in 1 year? Definitely, Kunal, you can, but it needs double the effort because usually students take 2 years. So if you are ready to put in double the effort, yes, it is possible. Watch my lecture. Can I still crack it now? If you're not able to find it, leave a comment after the lecture is over. I'll ping you or reply to your comment which video you should watch and what are the different things you need to do to crack JEE in 1 year. Okay. Bye bye, Rajvinder. Take care. And RLR Entertainment, can you just ping me again on Instagram and tell me that this was your name so that I remember and reply to you? Okay. Yes, I will definitely reply to you, RLR Entertainment. Take care. Hasta la vista. This was Capto Shreyas signing off.